Thank you very much. Do you hear me right if I speak like this? Thank you for attending my talk. Everyone knows that code quality is a big issue in data science, and we are specializing in advocating best practices and figuring out how to adopt software engineering practices to machine learning and data science. And this is part of the talk. These are highly usable, tactical code changing practices that you can use on your work. So I hope you are going to enjoy my talk. Right? I'd like to start my presentation with a classic aviation quote, which says, if it looks good, it flies good. This means that as engineers, we have this kind of aesthetic understanding of our problems and the solutions, what we try to solve, and we try to make them look good. And we understand that this is somehow brings some kind of quality into our solutions because these are somehow innately closer. Thank you very much. The title of my talk is Code Smells in Data Science, and what can we do about them? We will going to look at why do we care about this, what is code smell, and how do we improve readability. We are going to look at a couple of relevant concepts like primitive obsession, dependency injection, what are guard clauses, and what do we mean by the happy path. About me. So my background is in finance. I spent some time in mobile gaming. I was head of data science at a London fintech, and we did industrial scale natural language processing for investment banks. They are pretty demanding companies, and most of our knowledge on software engineering has come from these efforts. Now I teach data scientists to write better code, and I'm also a startup ML consultants. I have a blog, please check it out, called Laszlo.substack.com. And we have a community that is dedicated to improving the coding standards of data scientists on Discord. Please go to this URL, cq4ds.com, where you can join and take part in the conversation if you really like the talk of this. First of all, why do we care about code quality and readability? Programming is communication. You are trying to express to someone else what your computers want to do. And this communication needs a language. You are talking about your code all the time. And if you don't speak this language, it makes it hard, and it makes others who you are working with hard to understand what you try to do. The code is the primary medium of that, so it needs to be transferred in this code. We also read much more than we write. If you write a line of code, several people in your team will going to read it, and you are going to read it later if you want to change this code. Also, if we find issues with our code and we would like to improve it, we would like to have standardized processes of how to fix this and not reinvent the wheel every time we see a bad variable name. And all of these are point towards a drive for productivity. We are not doing this for just because we want to beautify our code. We want to be more efficient. And as we see it in the first page in the aviation code, a better looking code is going to be a more effective code. And these are pure cost saving and efficiency attempts. First of all, the main topic of the talk is code smells, and I would like to introduce what code smell means. A code smell is very important to understand is not a bug. Your code can perfectly operate as it should, and it's not going to cause any problems if it has code smells. It also doesn't need immediate attention. If you have a bug in your code, you need to write a test. The test should fail, and then you fix that bug. But a code smell can stay in your code base until a long time. And it's also not technical that code smell is usually a very tactical, a localized problem with your code base that you need to fix at some point. And usually this happens during what's called code rot, when you are updating your code base without actually checking the quality. And then you start creating these problems. And I'm going to share two examples of these, and you're going to see how code rots. Code smells might cause problems. It's usually prevents change, and you recognize that your code has smell or someone else's code smell, because obviously you're not writing smelly code, someone else is writing it, right? Um, but it prevents you to change when you have a request to change somehow the performance of the code base. And also code smells have a well-named taxonomy. We are going to list some of these. I'm not going to list all of them because there's so many. There's so many ways to write bad code, and all of them has a name. But I'm going to focus on a couple of important ones. And then if you like this topic, you can go and do extensive studies on that. And code smells themselves has a recipe to resolve themselves. So it means that once you can name a code smell, there is a recipe that you want to go through, and that recipe will going to resolve this code. And this makes it a very efficient way of communicating about that, because in a code review, you can just point to a point in the code and say, this is this code smell, and go and fix it. And then the person who's created this pull request can resolve this problem. This is in Unity, it's called refactoring. Refactoring, this came from this book. Please read this. This is like a standard text in the topic. Refactoring means changing the code without changing its behavior. Just read this. It's very important text. The second version is in JavaScript, which is pretty comparable to Python, and the concepts how they go through is very thorough. Obviously, refactoring requires testing, but this talk is too short for going into that. So please check out my last year's talk on clean architecture and technical debt, and that goes extensively on how to write testable code. Okay, so we are here now. So we are going to talk about readability first. Readability is a separate issue from code smell, but as equally important. Then we are going to look into a couple of codes to describe, this taxonomy. Then we are going to look into very briefly how to establish a culture around this and what to do and how to utilize this knowledge. So first of all, let's take a readability of this code. You can see this 20 lines. It does a lot of things, for example, it gets some kind of values and some kind of threshold. It's calculate average above threshold, it's at least it's well named, so you kind of know what it's going to do. Then you can walk through it. So it checks the parameters and then does a for loop, calculates some kind of value, and then throws some errors if the parameters were incorrect in this in the inputs. But let's try to look each line and then see how we can make it better. And then I'm going to introduce a couple of concepts, what you can look at your code and then change it. So the first problem here, it's pretty difficult to see, but it has dead and unreachable code. These are just clutter in your code base, and you should remove them. If there is any reason to save these, that's why you use a version control system, because it is going to be stay there. You can go back there and then check it if you accidentally need it, but now you don't need it. If you look at this line is unreachable, because obviously it's hard to see because there is like so many branches and exit points on this function, but that you can't reach this anyway. So you delete this code. The next thing, what I would like to draw your attention for is a second line, which is a comment. It's pretty dark, but it says, will store the total, and then it says temp equals 0. If you have a variable name, why don't you use that first? So write code that explains itself and doesn't need comments, and delete the comments themselves that are explained. Comments are only for docstrings, describing your code base. So you can just delete it and then refactor every occurrence of the variable, and now it's much better readable. There is also a tendency to use excess variables where you are creating names that are unnecessary. We know that naming is one of the hardest problems in computer science, so the easiest way is to not name things. And the solution for that is to inline these variables, right? So what you can do, you can look at this part where you are creating the average value, and then the only thing you do with it is to return it. So there is nothing wrong with returning a formula, and the person who's going to read this, you need to read less lines of code. The next one, we are starting to get into more convoluted readability issues, what's called improper variable scoping. It means that you are creating a variable far away from the place when you are going to use it. And this means that if your code does a lot of things, these codes parts are going to be entangled and it's going to be difficult to modularize. So in a tactical level, you want to move these usages and creations of variables close to each other and therefore creating like natural segments in the code. And then you can decide later that you move these into different modules, right? So you can take a look at here. So this total and the k variables are created there, but they're only used later. It would be better if they are only used if they are, the function goes into the main part of the code. And you can just move this closer. This is not really an expensive operation. You just structure your code better, and now things that belong together are closer to each other, and then more your code is more coherent. Obviously, this is a simple example, but you can imagine that if this is some kind of algorithmic calculation, you would have, several lines between them, and this would be a much harder problem to do. The second step I would like to reflect on is, the left side of the code is very jagged. There is like a lot of levels. Your eye needs to move sideways when you are reading this code. It's not like reading a poem, it's more like reading some kind of winding road, right? And that's because you are using a lot of if statements. And these are creating these kind of weird branches. So what you can do is to identify these 3 points at the bottom. What do these do? All right. If there is some kind of special condition, then it throws an error. These are called guard clauses. It means that it stops the function to operate in certain situations. And these guard clauses should be at the very beginning of the code. Why? Because it means that if the input variables in certain special situations that should stop running into the main branch of the code, it should fail immediately. So someone who is coming in late into your reading your code and needs to think is like, what happens if one of these variables is none? They don't need to understand how you are going to calculate the end result because they don't care about this. They only care about the part where they are throwing the error. All right. So these are guard clauses, and you need to move this at the top. And obviously, you don't need an if statement anymore because you're not going to reach the main body of the code. So you can move it to the left most part of the code. The other part, which is typical in this unreadable codes, is for loops. Python is particularly useful to use comprehensions instead of for loops, and this is very Pythonic, so you should use them as much as possible. So take a look at here, and you can replace it with one line. Obviously, none of these are rules. It means that you need to make conscious decisions whether this code is readable than the one which I've shown you previously. All right. So it means that it doesn't mean that every time you need to use a comprehension, even if it makes your code unreadable. The last one is multiple exit points. A well-written function has one exit point, and that exit point is the very last statement in the code. So you can see here that you have two exit points because if you try to calculate an average and one of them is zero, you don't want to have a zero division, so you return a none. We are not arguing with the writing of this code. Like, since I'm talking about this, we didn't change anything about that because this is refactoring. So it means that we are not arguing how it is written. We only change it how it is structured. So if someone decided to return a none, if instead of raising an error or something, then we are not arguing with that. But you can calculate the entire function in a single expression and then return this value, and also remove duplication of calculating the length of the value. And this is a much more readable structure in this way. Let's take a look at how it was before and how it is now. Obviously, it's much less code, but it's very important to emphasize that the number of code lines is not a goal to minimize, right? So readability is the goal. It's one, situation that usually badly written code is much longer, because some of the techniques are explicitly making your code shorter, but it's not a goal what you are optimizing. So if you can make it a bit longer and more readable, so for example, the comprehension is more complicated and you want to extract some kind of function from it, then it's a perfectly fine thing to make it longer. So what are the outcomes from this readability exercise? The code is one continuous logical flow. You can just read it from the top to the bottom. You have a guard closes at the top. So it means that if you need to exit from it for whatever reasons, you can do that. The happy path, so where the main body of the code happens, is on the left in one list of statements. The variable cycle is contained. You get the values, and then in line 8, you turn that into the relevant values, and after that, you are only dependent on this function. And that is a good structure as well. Obviously, if you have more complicated data flow issues, then this would be more convoluted, but this is a simple example for that. And the return is in the last line. So you know that this is the point where you are going to exit. And if someone just wants to know what's happening in the output, he's just going to need to read the last line, right? And what this is returning. Cool. Okay, so now we can get into the code smell. So that was the setup, right? And we're going to look at another example. Look at this beast, what does it do? It it's called get active users, and it gets roughly maybe 10 15 parameters, ton of variables. You know that this is a problem area. You need to change this. You are going to worry, right? Because if it breaks, something, a live service, we're going to go down. So what does it do? Obviously get ton of user data, a ton of, like, maybe it's transaction data. It says amounts and values and cutoff threshold, whatever. It just rotates and calculates some kind of totals, and then either prints into a file or prints into the screen, right? And please take a look at this beauty of using in a loop a file opener, right, with an append statement, because obviously you know that someone was hacking this, all right? You know that they inserted this issue later. So we are going to look into a couple of typical situations, what here, and we're going to name them, and then we're going to tell you what we're going to happen with it. So the first set, what you need to learn about is what's called bloaters. These bloaters can have many forms. One of them is like long parameter list. Yeah, check that we have that. Data clumps. Data clumps happen when you have a set of variables and they happen all the time in the same order and same list. If you ever try to create any kind of training samples and you have an input and output several times in your code base, then you have data clumps. And there is a third concept, is called primitive obsession, which means that you are continuously using primitive types, strings, lists, floating points, just purely as the basic types and not wrapped into some kind of meaningful classes. So what's it? You can take a look at. Sorry, I was just not. But essentially, you can see the points where this is happening. So the first one is the long parameter list, and then you have the data clumps, and at the bottom you have data clumps again because you are unable to create any other way the string what you want to print. Obviously someone was copy pasting the code, but we are here to fix this. What's the solution? The solution is extracting classes. Because you are dealing with get active users, you are dealing with users. Where are the users? All right. You're dealing with transactions. Where are the transactions? And naming them is giving you a huge advantage. You can see how many times the code was changed during this refactoring step because it was so entangled, this part of the code, with this concept of users and transactions. All right. So first we are creating a data class for the transactions. Then we are creating a data class for the users. Instead of putting it a ton of pieces of information in primitives, we are inserting into this function the user class, iterating through the users instead of its components. Then we use the transactions inside the users, and that's a problem, but we are going to look into this later. And then we are handling these active users separately. So what's the next step? Obviously, I said that we are going to deal with the transactions later. So what's happening? What does feature envy means? Feature envy means when you have a class, it stores some kind of information, and then you go to that class, take the information out, process it yourself, and then pass on the information. You shouldn't do that. What you should do is you are passing the request to the class which owns this data, process it there, and then get the result back. That's called feature envy. We are going to see it here with the transactions, and of course we are seeing it here with the user names and ID as well. When you are getting the information out of the users, do something with it and then go on your business. These are our code smells because this piece of code need to change anytime you are changing the data class. You're not supposed to do that. You're supposed to ask a request from the class, and then it should return the value to this. So how can we do that? We simply move the part of the code that was responsible processing this data to the class where it is which owns this data. You can identify these points here by any time you are using a property of a class. Those might be code smells, and it's important to emphasize these are might be code smells. It doesn't mean that you always do this, but that's where you start looking. All right, so you move this code and it says get total since, all right, and then this is a much more meaningful number because you know that okay, we're going to go through the transactions since this point in time, and then we are going to calculate what's the total of the number. And we can do the same thing with printing the user information into a file or a print, and move this to this two-line function. Obviously, you can use the string method or double-under methods as well, but here I want to make a point regarding this. Okay, let's do a refactoring step, like what we learned in the previous session. Take a look at here, the active users. What happens later? The user is get called in a loop. We learned that for loops should be replaced with a comprehension if we can do, and then let's do that. So now it's much cleaner because before you can look at this weird appending to a text file, you know that this is going to be wrong because it means that if you have 1,000 users, you're going to open that file 1,000 times. That's an overhead, definitely. And that was now gone because obviously the active users are present in one go. And then you have this kind of two separate structures of dealing whether into a printing into a file or printing into a stream. Of course, now we can go into probably not a code smell, but more what's called an antipattern, which is just a different name for code smells, what's called a Boolean parameter. Take a look at this save to file. Now, this is the point where someone was hacking into this function. They just added at the parameter list, a Boolean parameter to whether to save into a file or not, and then a file name. The problem here is that if that save to file is false, what is file name? I should not insert it. I still need to write some kind of fake file name there because it doesn't have a default value. So the function where I'm calling it, we're going to ask for that. But here it later, if it's if you're saving to a file, one branch runs, but if it's not, then another branch runs. The problem is what happens if I don't want to run either of them? Shall I add another Boolean variable? And this is a typical problem for if you have like logics where different things needs to happen in different circumstances. And we are going to look at a more involved way of refactoring that. And this way is called dependency injection, where we are going to inject this functionality, whether this service should print into a file or into the screen. So the first step is to wrap the entire function with a class. You can see the constructor doesn't do anything. The code as it is moved into this class, and we instantiate it in a main function and then call this function as it was. There is nothing happened here that wasn't there before. Here at the bottom, we are instantiating it and then calling the function. And then we move the code that printed into a file into its own class, right? So that's a very important step. We can see that the output function is just a piece of code that was responsible for printing into this file. And the file name is part of the constructor of this output class. This is you can write an interface for this. This is a way to get user information to some place. It's called a strategy pattern. And then you inject this strategy as a parameter into a class when you are constructing it later, right? But here, in the original function, it is only 3 lines now. So we are we are refactoring this into almost nothing. But essentially, you are not doing anything. The service doesn't know where the users are going to go. It just knows that it needs to call that function, and this is called the dependency injection. And because it doesn't know where it goes, it's not dependent on these outputs. And the last one is just okay, sorry. And that's it, right? So it means that in this function, we are doing exactly the same thing, but we are printing into a file because this is how we set this part of up. What happens if I want to print into somewhere else? I can just write a different class and instantiate it at the bottom into the main function, but I do not need to change the service which I was refactoring. So it means that it is independent of a detail. And we can also have future options which are not present here and we cannot do it before. And there was no easy way to do that. For example, not printing anywhere, right? We don't need to change the original code. We just write a different output class that is going, throw it into the air, these, and not doing anything about that, right? And then use that in the instantiation. And the last option is we can use both of them. And then I'm going to, telegraph you a different topic related to design patterns. This is called a composite design pattern, where you are creating one class that is actually 2 classes combined into one, and instantiate that. And your original code now can print both into a file and into the screen, and you don't need to change it. And this kind of optionality, when you are discovering, indicate that your code is well structured, because you can create new ideas and new features in a relatively easy way and decomposed way. And the last, this is, I promise you, this is, I know this is a lot. There's more than 70 slides here. But this is the last set of code smells, which is called couplers. You can see that everywhere. They have different names, but usually when you are refactoring, some of your classes will go into empty, and they are not doing anything anymore because you moved all of the information into other classes. And you consciously need to review your structure of your code and the code base, and then throw these out. So for example, empty class, a class that lost all of its responsibilities. There is middleman, which is just a step between 2 things that are doing something, but itself doesn't do something. Message chain happens when someone gets a parameters, and all its job is to send these parameters to other classes. These are all just extra code, and there is what's called speculative generality, which means that you were thinking that I'm going to need it later, but actually didn't need it. If you think that you need something in the future, make it right then. Don't try to be extra attention, because someone will going to need to read that code 10 times, and you're going to just waste that person's time. We can write it later. What's the solution for that? You just delete the class. We spend so much time writing it, but essentially we figured this out, that you don't need anything. You want only, you want only something that prints users, and you want something that filters users, and you translate all of this code into the relevant places, and the service that is doing this is useless. Okay, so let's take a look at here. What was it before? So you can see the function on the left-hand side in its original form, and then in its refactored form, you can see that the function doesn't exist anymore. You are just operating on the domain-specific classes, and then you have this kind of functionality to send these domain-specific classes to some kind of serialization. And you can see here that the code is actually longer than it was before, but that's not a problem, because the goal is readability and then composition of the codes, better composition of the code. right? So let's take a look, and then I only have 2 slides left. It's important to take these practical advices and turn this into an internal culture in a team. Writing code is a team sport. You are the primary medium is the code base, what you are communicating through. And code review is the primary event where this communication happen. So don't think about this as someone checking your work. You are essentially asking a question for someone else of, do you get it what I did? All right. And that person needs to look at this and say, yes, I do get it. If this doesn't happen, at that point, in 3 months' time, you are not going to remember what you wrote either. So in 3 months is the time that it takes someone to forget what was his own code base if they don't look at this. So actually, you are helping yourself by doing code review. The total cost of ownership is important for anything that is used for more than a couple of days. You write a pandas notebook-based code in a Jupyter notebook. Do you want to review it? Probably not. But anything that is have a life cycle of more than a couple of weeks, and certainly more than one people we're going to look at this, is going to have a high TCO. So it means that you need to spend energy on it to improve the quality. Also, these kind of code quality exercises help you to increase developer happiness. It's important that you are proud of what you are doing, and to be a proper professional and a craftsperson, you want to increase these skills to write better code and be proud of your work, and then increase the relatedness. And all 3 of these will going to be improved if you take care of your own code base. And all of these efforts, it's important that you personally drive this cultural change, you advocate, other people feel about the code base like this. And then in 30 minutes, I explain to you a significant chunk of this body. If you go away and then practice this, you are going to improve your craftspersonship very quickly. And all of these, often you hear that, oh, we are in the experimentation stage and we are going to care about it later. This is just putting it off and doesn't allow you to improve your skills on an ongoing basis. And it is proven that high velocity and highly changing environments require high level of code quality, and that's an added value, not a cost center. Let's take a look at the takeaways and then we can wrap it up. So programming is communication. You concentrate on the data flow, how the information flows through your code base. You approach your code base by identify problem areas. You prepare the code. We see a long section on that, how to improve the readability in general of the code base. Then you identify the code smells, and the code smells have a set of steps that you need to go through and fix these. So it's a relatively low intellectual activity. So you can do it by routine. You just need to practice a lot. And you need to evaluate the TCO of the code. So you need to look at this and then see, do I want to keep this on a long period of time? Because then it's probably a good idea to fix this. And establish a culture, advocate this to other people, establish a reviewing culture, which is blameless, but to the point, and you are arguing about code, you're not criticizing someone else's skill set. It's a very, very important thing that a code review should be a positive activity. You are helping other people and they are helping you as well. Right? I have a blog. I write about this regularly, and please join our community at cq4ds.com. Thank you very much for your attention. Anyone has any questions?
Hi, thanks for the interesting talk. I was wondering, I didn't see typings in your examples. So what are your thoughts on duck typing in Python versus making typing more explicit?
That's a very good. And I've never put typing into this because there is already a lot of code on the screen, so I leave it out. It's a very important concept, but I would usually identify this as a coding exercise, right? So that's a feature of your code. You know, you want to maintain types. That's very important, but that's not a code smell if you don't have it. Does it make sense? It's more like a source of bugs, and then you can answer these bugs by typing. But I do agree with you that it's an important concept.
Yeah. Thanks for the talk. It's more of an observation and an opinion rather than a question. But to me, another code smell is when you have a class that only has one method, it's essentially do it. Replace the class with a function that makes it okay, more flexible.
Yep.
The caller can use a lambda or a function, or if they want a class, they can have a class with a callable method.
You are kind of right. I would argue that sometimes this is a typical example. The file output is a typical example that has a parameter, and then there is not really easy way to pass this parameter if you are using a function. Usually partial evaluation of functions is usually the answer, but that's not really a feature in that anyone is using. But uh, what you mentioned is explicitly the empty class, can be the empty class smell. So you need to make this call. It's like, do you have this situation that I actually have an awkward way of passing some values or containing some kind of information together, or not? And if it's not, then definitely move with a local function, for example. I must admit that there was another example when I was using a local function, but I need to cut the content.
It might sound a little bit like nitpicking, but it showed up a couple of times. I'm just curious. I understand the time complexity remains the same, but when you do list comprehension beforehand, and like list the list again, you kind of double in the runtime.
Yep.
So would you say that's kind of a compromise or a good price to pay for the readability?
Yeah, that's a very good question, and thank you for asking it. Um, like, there is this quote called "premature optimization is the root of all evil," which I kind of disagree in data science situations, because data science and especially statistical analysis is the only place where you might not have a feasible solution if you don't optimize too early, right? Parallelization, extremely large memory, distributed computing, and these are all exist early on because otherwise you would not have a solution, right? Saying this, usually at this level, you should not worry about that, right? Like your pure focus should be on writing readable code, especially if you are in a high velocity environment, so you are changing your code base a lot. So, and then you are looking for hotspots, right? So use TQDM to analyze just the overall time. If your code runs for 5 minutes, replacing a for loop and something is not going to help you, right? It's important to know the difference between a hash table, so a dictionary, and a list. That's an important situation. What else there is? And if you identify a hotspot, then optimize that hotspot only, right? Not everywhere else, because it's almost always we're going to ruin your code, your readability. And maybe you can wrap this with a function or wrap this with a class and then write a slow version, which is readable, and then optimized version, which is less readable, right? Thank you.
Thank you, Laszlo, for answering all the questions. We are out of time.
Okay, I'm going to be here, so we can talk about it.
Great. So thank you for Laszlo for the session. Thank you guys for.